Okay, so today on integration, we are going to be finding the area between two curves. Okay, so as you can see here, we're asked to find the area enclosed between F and G. So this shaded area between the line and the curve. Okay, so very simple. Normally when, or up to now when we have been looking at, say, the area below a curve or below a function, we have integrated and we have known our limits. So we've known what this point here was and what this x value here was. Okay, here we don't obviously know that, but how do we work it out? We first of all, we find the intersection of the two functions. So that's the first part. Step one, find intersection. Okay, so we find the points of intersection. So for example, we might call those, they might be at x equal to a and x equal to b. So these are now the bounds that we are going to integrate between, and so we subtract the integrals of the functions. So a is going to be equal to the integral from a to b of f of x with respect to x minus the integral from a to b of g of x also with respect to x. Okay, so that's our formula here for integrating between two functions, or finding the area enclosed between two functions. This formula also works for any kind of functions where one of the functions, or both maybe, where the area goes below the x-axis, as you can see in this diagram here. So this formula is how we will take or use them from here on in. So always you're going, f of x is obviously the upper bound of the area, and g of x, the one that's subtracted, is always the lower bound, and the values a and b are the points of intersection. Okay, so let's get started with this question. Okay, so here we have our two functions. So g of x is equal to x squared and f of x is equal to x plus 2. So let's put the two functions equal to each other so that we can find our points of intersection. So very quickly then we see we have a quadratic equation to solve. So that's x squared minus x minus 2 equal to 0. So it's x and x, 2 and 1. 1 has to be positive, 1 has to be minus. 2 produces, this one in the middle produces the bigger result. So we want that to be minus because obviously here is a minus. Okay, and so that means that here we have to have a plus. Okay, and so just finishing that off, we have x equal to 2 and x equal to minus 1. So they are now going to be the bounds for which we integrate. And so just marking them into our diagram here. Okay, so now that we have our values, minus 1 and 2, it's just our regular integration. And so off we go. Here we have a is equal to the integral from minus 1 up as far as 2 of f of x, which is x plus 2 dx. And we're taking away from that the integral from minus 1 to 2 of g of x, which this time is x squared, and that's also with respect to x. So here we have a is equal to, well, that's x squared over 2 plus 2x between 2 and minus 1 minus the area here, that's going to be x cubed over 3 between also 2 and minus 1. And so it's just our regular definite integration here, and so let's finish it off. So that's it all substituted in. So when we work that out or put it into our calculators, that gives us a equal to 4.5 units squared. Okay, so let's have a look at another one. Okay, so here we are asked to find the area enclosed between the curve f of x equal to x squared plus 5 and the curve g of x equal to 21 over 16 times x squared. Okay, so the first thing that we have to do is to again find the points of intersection of the two curves. So the first thing we have is x squared plus 5 is equal to 21x squared all over 16. So multiplying across by 16, that gives us 16x squared. 16 times 5 is 80, is equal to 21x squared. So all to one side. That's going to be minus 16x squared, minus 16x squared, minus 80, minus 80. Okay, so cancel and cancel, and that gives us 5x squared minus 80 is equal to 0. So dividing across by 5, that gives us x squared minus 16 is equal to 0. So x squared is equal to 16, and x is equal to plus and minus 4. So there now are 2 points, are 2 x values for the points of intersection, and they are now our bounds for our integration. So we'll just put those aside over here. And so as we've said before, area is gotten from the integration of both of those and the lower curve subtracted from the higher curve. So here our higher curve again is f of x. So we will begin here and say, well, area is equal to the integral between minus 4 and 4 of f of x, x squared plus 5 dx minus the integral from minus 4 to 4 and g of x, 21 x squared all over 16, and that's with respect to x. Okay, and so let's integrate here, and we get a equal to, well, x squared becomes x cubed over 3 plus 5x, and that's between minus 4 and 4, subtracting 21x cubed. X cubed divided by 3, so that's going to be 7x cubed all over 16, and that's again between minus 4 and 4. Okay, and so just going to substitute in again for our 4 and minus 4 values. Okay, so now that we have that substituted in, you can stick all of that into your calculator and see, or you can do it each part. And when you do, we should get, so A is equal to 80 over 3, or 26 and 2/3 units squared. Okay, so all we can see with the integration of the area between two curves is that it's our regular definite integration, and to find our lower bounds and upper bounds of the integrals, we just find the point of intersection of the two functions by putting them equal to each other and solving for the variable involved. Okay, so make sure you get all of these notes written into your copy, and there'll be some questions on Schoology to go with it.